वसीम अहमद खान साहब को रिक्वेस्ट होगी प्लीज तो स्टेज पे आ जाएं।
Bismillahirrahmanirrahim. Session Chair, Session Secretary, Honorable guests, students, thank you very much, and I'm honored by IEEEP Pakistan. I'm presenting the work of my students when I was a professor at GIK Institute. They are unable to travel to the events. They are unable to travel to the event because of the disturbance on the road currently happening in Sindh. I'm presenting the design of a smart transformer that can be used, and we have also designed the online monitoring system of these smart transformers so that a preemptive power failure, a preemptive failure of the transformer can be detected using machine learning. Next slide. The agenda is the concept, the monitoring methodology, the CFD analysis, thermal monitoring, magnetism monitoring, ECP, data analytics, and the benefits. Next slide, please. The concept. Next slide. It is the basic concept, the generation, the power generation, the power distribution, and the monitoring of it. It is depicted in the picture, which you can see yourself. Next slide. Next slide. We are using standard transformer geometry to convert to digital twinning. You have to model the physics of the transformer, and we are using a standard transformer, which is IEEEP 60076-1. Previous slide. The standard has many parameters. It relates to its geometry, and that leads to different capacities of the transformer. And there are three important parameters in the transformer. Number one, the magnetism. Number two, the fluidics. Number three, the thermal. Next slide, please. Next slide. We're using industry 4.0 pillars. Here, I'm presenting only three pillars. One of it is industrial Internet of Things. Number two is cloud. And number three is data analytics. We have presented our work to K Electric, and we are using around 6 of these pillars, which I'm not going to present here at this moment. Next slide, please. The smart transformer. The smart transformer can detect these three parameters, which I just said: the thermal, the fluidic, the oil temperature, and its velocity, and the magnetism at different positions, using physical sensors and the virtual sensor. Our knowledge of virtual sensor will only be used for the magnetism. Next slide, please. The monitoring methodology. Next slide, please. This is the schema for monitoring methodology. We have some software and hardware installed at the transformer, and through cloud we are taking. I'm sorry you have been bothered by the internet connection number of times in this event since morning. So please don't ask questions about the efficiency of this concept. This is just a concept and a design, and we have proposed a cover to it, how to get rid of, and there are proposals that smart link will be here. Smart link will be here as well. So hopefully we'll get rid of it, inshallah. So we are using some software and some hardware at the transformer, and we are using a microcontroller at the transformer. It can be extended to a full-blown computer at the transformer, and it uses a thin client which basically transfers the data to the cloud that ultimately pass it to the transfer manufacturer server and the distribution company servers. There, the full-blown models, the full-blown application packages of the fluidics simulation, thermal simulation, and magnetism simulation software apps are present. And these software apps are written there. These are ANSYS, the work has been done with ANSYS, the workbench, ANSYS Fluent, and the third one which is ANSYS Discovery. And the third one is the ANSYS Discovery. The transfer manufacturer gets the information for design improvement. On the other hand, the distribution company gets the information for a control of the PNG directly, or control of the smart meter based on the payment of the bills. Next slide, please. This is the CFD simulation of the transformer. Next slide, please. This is the fluidic simulation, flow simulation, which is there. Okay, it's showing the flow of oil in meter per second in different color. Next slide, please. These are the temperature profile of the oils, coolant oil. Next slide, please. This is using ANSYS Discovery. We are sensing the temperature. Next slide, please. This is in Kelvin. The temperature is in Kelvin at different places. Next slide, please. This is the heat plugs in watt per meter square. Next slide, please. Section U temperature in Kelvin. Next slide, please. This is the section heat flux. Previous slide, please. Previous slide, please. Next slide, please. Magnetism using ANSYS. Electronic. Next slide, please. This is an example of magnetism in the core. This is the simulation. Again, this is slide simulation across windings. Next slide, please. Core cross section. Appropriate units are there. Next slide, please. Coil magnetic flux. Next slide, please. Current density. Next slide, please. Ohmic loss in coils. Next slide, please. Coil cross section में जो ohmic loss होगा. Next slide, please. Here I will stop. Now, the important thing is that we are using a concept called extended reality. Extended reality is based on reality, virtuality, continuum. There are four things in reality, virtuality, rather five things in reality, virtuality, continuum. Reality, virtual reality, mixed virtuality, and virtuality. If we can represent all these five states in one time, then it will become XR, or extended reality. Okay? So we are trying to predict extended reality using physical and virtual sensors. You see, we cannot sense magnetism. We cannot touch magnetism. It is unseen. You cannot see the magnetism. Okay? So, if we can sense magnetism, but for that, you have to incorporate sensors inside the transformer. But this is a long way that we have also proposed to KE, that that will go to the design table of the transformer manufacturer. In the meanwhile, we can use external sensors and virtual sensors. The virtual sensor is the mathematics that, next slide please. Next slide please. That works on this equation. Again, the equation is there. All the variables and their units like Tesla, Henry are given there. Okay. Now this mathematics and some more things are used, computed basically, continuously computed on the basis of, for the virtual sensors like magnetism, measuring previous slide please. इसके बाद previous slide please. ये बेटा वीडियो है, इसको सदन कीजिए. The values will be changing. Previous slide please. वीडियो है. No, चल रही है. So it's changing its value. This is the cross meter, and again used for measuring magnetism. Okay, and this is it is operated on the mathematics. Instead of having the glass meter outside the transformer, you can have it inside the core, working out the complete mathematics, considering the geometry of the transformer, which each of the transformer having different capacity has a different geometry. Okay, has a different coil, has a different number of cores. Cores maybe this, depending on the phase. Okay, next slide please. Next slide please. Okay, next slide. These are the circuits for PCBs. Now the PCB is not the insulator that we have been talking about in the morning. Okay. This is the printed circuit boards. This is the master-slave configuration. And in master-slave configuration, this is the slave microcontroller based on a microcontroller which is written there. Omega. Yeah, next slide please. This is the previous slide please. Raspberry Pi. Previous slide please. Previous slide please. Previous slide. This is the master controller controlled by Raspberry Pi, which is controlling 3 slave controller. Each slave microcontroller is controlling one parameter, the thermal parameter, the magnetism parameter, and the fluidic parameter. Okay. Next slide. Next slide. Next slide, please. Next slide, please. The data analytics, all the data is received at from all the transformers, thousands of transformers. I've been told by an expert of the KE today that there are around 34,000 PMTs installed in Karachi. Next slide, please. And you get our representation, statistical representation. The data is coming to the control room instantaneously. If the transformer is working fine, you let it go. If it is causing a problem, you record it, and by machine learning, you try to predict when its failure will occur, and then you accordingly intimate the salvage team, and they will be ready to salvage the transformer. Thank you very much.